Good afternoon, everyone. Today, I'm going to talk about the seismicity in Madagascar, but not all of the magnitudes, just the moderate ones. So, first of all, I'm not going to talk about the famous movie about Madagascar. I'm going to talk about the result of the breakup of Gondwana. You see in the red circle, Madagascar between Africa and India, and geographically, it's now near Africa. Okay, when you look at the seismicity, almost of the earthquakes are in the center, as you see. And you see in the west, there are three groups of earthquakes in the west, and then you see also in the red circle in the east and in the south. In Madagascar, we have not big earthquakes like 7 magnitudes or more, because when you look at the map of the world, then you cannot find any big magnitude. So Madagascar is not really don't have this kind of earthquakes. There are so many studies that have made about Madagascar, so I'll cite some of them. Like you see for the first map in your left, it is a study from Sarah Stamps in 2008 and 18. There is also, for the second map, you see the movement of tectonic plate in Somalian plate and Luandel and what else from Saria. But first of all, there was a theory of Hatnadi that tell us there is some microplates beneath Madagascar, so we don't know yet if it's true or not. There is also some study that say that Madagascar has an extension to east-west, because Madagascar is part of the East African Rift System. There is also a study of the lithosphere of Madagascar, as you see in those maps. The thing that we see here is that in the center part, the velocity of the P and S waves are slow, as you can see there. The first one is the study of our colleague Andrea Penman, and the second one from Pratt. There is also a colleague, Razon Arson, that shows that there is a extension east-west because of the mantle flow and upwelling beneath Madagascar. And me also, I've done 3D tomography that shows that in the center part in the volcanic area, the velocity of P waves are very slow. So that means that the crust in these areas are not very hard. Okay, so let's move. When you look again at the seismic map, in this I emphasize, I put in there, they say the earthquakes with a magnitude above 5 Richter, not Richter, but the magnitude, local magnitude with 5 or above this in the first map. And when you look closely, you see that there are 2 lines of epicenter. The first one has an extension northwest, and the southeast. And the second one you see in this northeast, south to the center, so it's not east. What really happened there? So is the East African rift extending to Madagascar really, or there is something else, or the result of this dam swell? Maybe you have seen the movie of Ice Age, but let's see. So before this, I have done relocation of all of these moderate earthquakes. So when I did the relocation, some of the earthquakes are not really 5 or more above this, the magnitudes, but some of them became 4 or less of that. And some of the earthquakes, the waveforms are lost, so I cannot relocate them anymore. But after relocation, I took all of the earthquakes that I have relocated. So you can see in this second map, the relocated earthquake, but with magnitude above 4. Then we see that most of them are in the center and in the north in this second map. So now I did the focal mechanism again. So what we can see that almost of the focal mechanisms are normal faults. That means that there is really extension in Madagascar, as we see before in the previous study. You see in the arrows the movement of the plates, and the direction you see in those two maps. So I'll go here. So there is really an extension to the east-west of Madagascar, but we cannot say which theory is true. Is it really from the extension of East African rift, or is it from microplates? So it's like Schrödinger cats of Schrödinger. So both theories are still true until you can find which one is really true of them. So in this map, because of all of the forces, all of the movement in the lithosphere of Madagascar, there is extension. So Madagascar is like a bread in the oven. When you put the bread in the oven, it pumps, and then there is extension. So right now, Madagascar is like this, but unfortunately, you can eat the crust of Madagascar, but instead of that, there is earthquakes. So the moderate earthquakes of Madagascar are from this extension. So to end this, despite all of these studies, we cannot say, as I said before, what really happened in Madagascar, which theories are true, which theories are the bad ones. But at the moment, both theories are true. And as I said before, almost of the earthquakes, I cannot say almost of the earthquakes in Madagascar are because of this extension. And we can say also that we might have reactivation of volcanoes in Madagascar because of these frictions and those earthquakes. It is possible that there might be volcanoes one day, and as we saw before, the earthquakes, the crust of Madagascar is thin in the center, and the velocity in the part that there were volcanoes before are slow, so it is possible one day. We don't know yet, but we have some challenges. The problem is that we don't have enough station. This is like a church bell ring that this problem, you have heard this yesterday, but you heard it today, and then you will hear it in the next day, because we cannot solve this in short time. We need time to get more station, and the second problem is the distributions of this station. Almost of the stations are in the center part. That's why when you go back to the seismic map again, there are many epicenters in the north and in the south, but almost of the epicenters are in the north, because most of the stations are in the center, so we have to solve this problem also. So to end my presentation, I want to thank everyone of this opportunity and your attendance.
We have time for a question or two. Yeah.
I don't want to be the only person to have questions, but I have a couple of them. Congratulations for your presentation. In fact, Madagascar is a favorite destination for me, and I hope that I will visit your beautiful country. Could you please let us know what is the time interval that your catalog covers, and what is the density of your regional seismological network? And then the second question is, how have you substantiated the shuffling, this spread model, only from a few fault plane solutions where you can only show the east-west extension? Thank you.
Okay. Thank you for the questions. The first question, it's about the density. No. Okay. It is from 1988 to 2025. And the second one, the density of the stations. The density, in fact, we have 12 to 11, because some station could be out of, and we have one in the north, and then in the south we have two, and most of them in the center, so 10 to 9 in the center. And the last one, I don't really understand.
You have some fault plane solutions. How have you based your model about the bread shuffling concerning the crust of Madagascar?
Okay. We have we have the fault plane solution. So as I said before, because of this, from the GPS studies to the fault plane solution, and okay. So the main, this is not a problem, but we need to do this also. to put more GPS stations to monitor how is the hate that Madagascar have when so we need this also to prove this theory. So I cannot say exactly. I can't answer exactly your question, but we need to study this.
Let's thank our speaker again, and we're going to move on.